Hello mga kabady, today we're going to test transistors. Now, testing transistor is easy as long as you treat it as a diode connected together. Of course, you connect it together by its same electrode, just like this one. The P electrode are connected together. So, we know how a diode works or conducts. It conducts by connecting a forward bias to its terminal. So just like this one, we connect a positive voltage to the P electrode and a negative voltage to the N electrode. Then the diode should conduct, or the base emitter should conduct. And we connect again the positive voltage to the base and negative voltage to the collector. Then the base collector should conduct. We have here another transistor. This one is PNP because both the negative terminals are connected together. So when we connect a negative voltage to the base and a positive voltage to the emitter, then base emitter should conduct, and we connect a positive voltage to the collector, a negative to the emitter, then base collector should conduct. Now, if you're going to reverse the voltage, both of these, emitter and collector, should not conduct. Because if it conducts, then something is wrong with the transistor. So let us proceed with a real transistor. Now, what we're going to do is to randomly connect the test pin to the terminals of the transistors. But first, let us take a look at the transistor. As you can see here, it has a flat surface, and this should be a reference that this is terminal 1, the center is terminal 2, and this one is terminal 3. Now first we're going to locate the base. Of course, we'll set our ohmmeter range to range times 1, and we'll adjust the meter to 0. Now we'll proceed with testing. To find the base, first we're going to connect the black to the first terminal and the red to the center. As you can see, there is a reading, so it might be that the first terminal or the second terminal is the base. So we're going to connect the red to the third terminal and see if there's a reading. There's no reading, so the center should be the base. So we'll return the red to the center. This time we'll move the black to the third. Now when we connect the black to the first and the third, you can see the reading. So this one is, or the base is the center. So this one is the base, the center terminal is the base. And this transistor is a PNP transistor. Yes, a PNP transistor, since we supplied a negative voltage to the center or the base. Now, if we're going to connect the black test pin to the center, to the base, and connect the red to the either first or third terminal, there should never be a movement in the meter because we're connecting, or we're applying a reverse voltage to the terminal, so there should be no needle movement at all. So this is how we know that the transistor is good. Now, how do we test for the emitter? How do we locate the emitter? Simple. We are going to use range times 10, and will remain the black test pin to the base. Here we go. So first we're going to connect the red to the third terminal, so there's no movement. So I guess this is the collector. Now we're going to connect the red test pin to the first terminal, and here we have a needle movement. So this first terminal is the emitter. Again, we're going to use range times 10 to locate the emitter because we cannot find the emitter using range times 1. So this one is the emitter. So in this transistor, once again, the first terminal is the emitter, the second is the base, and the third is the collector. Okay, so let us proceed with another transistor. Now here we have another transistor. So first, again, we're going to locate the base. So that is why we're using range times 1. So we'll connect the first or the black test pin to the first terminal. So there's no movement. Now we're going to move the black test pin to the center. As you can see, there is a movement. So this center terminal is the base. And since we supplied a positive voltage to this terminal or the second terminal base, so this one is an NPN transistor. Okay, so again, if you are going to try to connect the positive terminal or positive voltage to the base, it is expected that there is no movement when you connect the black test pin to the first and the third terminal, because if it moves, then this transistor is bad. And how do we find the emitter? So again, we're going to use range times 10, and we will still connect the red test pin to the base. Okay, so we're going to connect the black test pin to the first terminal. So there is a reading. So this one is the emitter, and we're going to connect this to the third terminal. So this one is the collector because there is no meter reading at all. So that is how we know the emitter, the base, and the collector terminal of a transistor. Okay, so again, to find the base, we're going to use range times 1. If we're going to find the emitter, we're going to use range times 10. And of course, when we do that, we apply the reverse voltage. Because when we find the base, we apply the forward voltage or forward bias. But when we look for the emitter, we apply the reverse bias and we use times 10. Here we have a power transistor. So most likely in a power transistor, this is most likely the base, the first terminal, and then the second terminal is the collector, and the third terminal is the emitter. So we're going to check. Again, range times 1 for the base, because we're going to apply a forward voltage or forward bias. So there is a reading. So it is confirmed that the first terminal is the base. But first, of course, let me remind you that the reading should not fall to 0. Otherwise, there is something wrong with your transistor. It should be between maybe 7 to 10 ohms when we use range times 1. Now, what kind of transistor is this? Now, this one is NPN transistor. Yes, NPN transistor, since we apply a positive voltage to the base. How about the emitter? Again, to find the emitter, we're going to use range times 10. No? Use range times 10. and we connect in reverse bias. So meaning we'll connect the positive here to the base. So let me change the range. So we are now at range times 10. As you can see, now we're going to connect the black to the center. Of course, it will not move because this is the collector. How about the third? There is a very, very slight reading. No? So this third terminal is the emitter. Now, is there another way to find the emitter? Yes, of course, there's another way to find the emitter of this transistor. So in this NPN transistor, we're just going to let go of the base. So we'll move the positive voltage and move it towards the other terminal, and we remain the red test pin or the negative voltage to the third terminal, and we're going to touch with our finger the base and the second terminal or the supposedly collector. Maybe this is the collector, so okay, we touch it. Now the needle moves towards a low resistance, so that means the diode is conducting since we are supplying a voltage to the base through the collector when we connect the collector to the base using our fingers. So it is expected that there is a needle movement. So this one is the emitter, the third terminal. Again, the center terminal is the collector, and the first terminal is the base. So here we have another power transistor, and as you can see with this power transistor, it has a metal case attached to its body. So this metal case is connected to the collector, so it's very easy to locate the transistor of the collector of this transistor. We'll just connect our test pin to the metal body, and then connect the other test pin to, of course, the terminal. And if we get a low resistance reading, just like that, 0, so this is the collector. Now, to locate the base, it should be easy again. We use range times 1. But of course, in this type of transistor, it is expected that this first terminal is the base, the center is the collector, and the third one is the emitter. So we're going to confirm if the first terminal is really the base. So we'll connect the positive or the black test pin to the first terminal. There is no reading. So we'll connect the positive, or not the positive, but the red test pin or the negative voltage to the first terminal, and the black to the other terminals. Now it has reading, it moves towards low resistance. So it is confirmed that the first terminal is the base, and this transistor is PNP. Yes, PNP transistor, since we connect a negative voltage to the base. Now we test for the emitter to confirm that this third terminal is the emitter. We apply a reverse bias, and of course we're going to use range times 10. So now we're going to connect the positive voltage to the base, and we're going to connect the red test pin to the third terminal, so it has a reading. So again, it confirms that this third terminal is the emitter. And if you connect this red test pin or negative voltage to the collector, there is no reading at all. Okay, so that is how we test a transistor with an ohmmeter. So again, in summary, we find the base of our transistor by connecting a forward bias to our transistor. But of course, we use the range times 1, and we find the emitter by using range times 10 times 10k in the reverse bias. So that's all for now. If you have any question, post your question in the comments below. So I hope to see you again in our next video. Bye.